Let's see now how work with the EFS system looks in practice. Let's take a look at the properties of our hard disk. Work with BitLocker results in the fact that the TPM module needs to be initiated, and then we can turn on BitLocker. In order to do so, we must not only have the right version, but also have the correct edition of Windows. The Enterprise Edition allows encryption, while the Professional does not. Since we're starting this process for the first time, we need to protect the key with an additional password, as we've already mentioned. This means that there will be 2 copies of the key. For the password to be safe, it has to be generated for us. We can also save it to a file and move it from the disk to a safer place. We can also print it or put it on a USB flash drive. The whole procedure after the initiation of the TPM module was almost ready. Clicking 2 more times would have started the encryption of disk C. Let's see now if the TPM module is initialized. More operations may be related to the TPM module. As can be seen, we can configure operations supported by a given TPM module. In our case, the TPM module has already been initialized, meaning it's been turned on and protected by a password. You can only turn off, reset, or clear the password. The TPM module that is prepared in this way is sufficient for the correct operation of BitLocker. From now, we encrypt the system disk or additional disks. However, working with the EFS system is a bit more complicated. On the disk, let's create a text file and save some text in it. Encryption results in the setting of a certain NTFS object attribute, file or folder. Open the object's advanced attributes, where we can compress or encrypt the file. When encrypting a file, we'll have the opportunity to see a warning telling us that folders rather than files should be encrypted. Folder encryption means encrypting all the files in that folder. In that case, why should we encrypt folders and not files? Because having an encrypted folder, newly created files in that folder will also be encrypted. Many programs, including programs in Office, create temporary copies of files with which we're working. If the folder is unencrypted and we work with an encrypted file, the created copies will not be encrypted. They should be deleted when we finish work, but that does not always happen. We, however, encrypt the file ourselves. What happened? We can see the file's encrypted, but its name is marked in a green font. We also had the opportunity to see that Windows cares for us. Since the computer issued us a certificate and ESF file, it now reminds us to copy and store it in a safe place, such as on a flash drive kept in a safe place. If something happens to our profile, we will still have problems with access to this file. Let's take a look now at the EFS attribute of this file. In fact, we're the only person that has access to the FEC key copy. There is no one else. There is no recovery agent. We do not belong to a domain, so there's no administrator who would care for these things. We also see that everyone has authorization to this file. It seems so. All users have full control. We'll see what happens now if someone tries to read the file. Switch now to the account of another user. Try to open the text file you created earlier. We have privileges to this file, but we cannot see its content. We can delete it though. Encryption protects the confidentiality of data and nothing more. We have mentioned this several times. If something is encrypted, it does not mean that it cannot be changed or deleted. In this module, we discussed technologies that allow protecting all data stored on hard disks. We focused on the encryption of entire disks, and in particular, the encryption using BitLocker technology. We also talked of how ESF technology complements BitLocker technology. I hope that the information in this module will help you ensure confidentiality of data, even if the data carrier falls into the wrong hands. Thank you.